Right, hello, welcome to your mock exam walkthrough. So you're welcome to go back and view this video as many times as you like to help you understand any of the questions that you struggled with on the mock. Okay, so let's get started with question number 1. Okay, so we've got an ester there. The structure of the ester A is shown below. What is the systematic name of ester A? So if you can see here in ester A, we have got a bromine on the end carbon there. The ester group is here, and in this section, 1, 2, 3 carbons. All right, remember there's no carbon there, that is the bond to the bromine. So 1, 2, 3 carbons, and on the other side of the ester functional group, there are 2 carbons there. Okay, so that means we've got an ethyl on this side, and we've got propanoate there. The bromine is part of the propanoate section. Now remember, if you were treating this as a carboxylic acid, if that was a H there, this would be carbon number 1, 1, 2, 3. We'd say this was 3-bromo-propanoic acid. So that is still carbon 1. Remember, naming of a molecule always starts with a carboxylic acid as if it's present, because that is the highest priority functional group. And the same in this case goes for the ester link. That therefore has to be the first carbon of this half of the molecule. And then this bit, the other R group, is treated separately. So this molecule would be called ethyl, which is that bit. 3, there's no hyphen, ethyl 3-bromo-propanoate. Okay, if you put a hyphen in there, it wouldn't make any difference at all. But ethyl 3-bromo-propanoate. Part 2. In the boxes, draw the organic products for the reactions of the functional groups in ester A shown below. Let's move it up a little bit there. So, same ester. Now, if you're looking, we're reacting the ester with a dilute acid, and we're reacting here with hydroxide ions. So, we're going to be hydrolyzing this molecule. We've got acid hydrolysis going upwards and alkaline hydrolysis coming down. Okay, so let's start with the acid hydrolysis. And remember, if you hydrolyze an ester under acidic conditions, you will produce a carboxylic acid and an alcohol. All right, so this one's quite straightforward. Don't worry about trying to change the structure. You've got, in skeletal formula, 3 carbons, keep it exactly the same. So 1, 2, 3, we've got the bromine on the end there. We've got double bond O, and then OH will be put back on to give us our carboxylic acid, and the other side then is going to be my alcohol. So that is just going to be I've done that wrong. Beg your pardon. That was like propanol, not ethanol. That's my bad. So we've got 1, 2 carbons, OH there, like that. On the bottom half, ester A now undergoing alkaline hydrolysis. With alkaline hydrolysis, you break the ester down, you form a carboxylate salt, because the carboxylic acid that could form reacts with the hydroxide ions to make a salt, and you get an alcohol. So we get exactly the same alcohol forming, ethanol, and we're going to get a carboxylate salt forming. So we've got there's my first carbon there, 1, 2, 3, double bond O, O minus. Now, this is where you've got to be careful. This is worth 5 marks for a reason. You've got 4 boxes, and there's 5 marks available. Now look very carefully. You've got a bromo, a halogen, essentially a haloalkane. Now we know haloalkanes can undergo substitution reactions in the presence of hydroxide ions. So that bromine is going to become a hydroxide. It's going to become an OH. It's going to become an alcohol. So there is your 5th mark for that one. Okay, not many students spot that one. So you've got to watch out any synthesis, look at the reactions, and think of it as a big picture. Part 3. Name the type of reactions of ester A shown in part 2. As I've already mentioned, we've got hydrolysis. So acid hydrolysis going upwards and alkaline coming down.